Hello, welcome back to another exciting day of online learning with Mr. Jolly. You guys, I am super pumped today to talk to you guys about one of my all-time favorite math words, which is sinusoidal. Today we're talking about the curves. So you guys might have seen these, you definitely have seen these before, but we're just going to approach it fresh as usual. So we're going to talk about the sine curve and the cosine curve mainly today, and then I think Mr. Street's going to talk to you guys about the tangent curve. If you ever forget where the sine curve and the cosine curve come from, they come from the unit circle. So let's just draw a quick unit circle. Your x, your y, and then in a different color. As you rotate around the circle, this is 0 radians. This is pi over 2 radians. This is pi. This is 3 pi over 2. And this is 2 pi. Now, what we're essentially going to do is take the sine curve as it travels around the circle and kind of unroll it onto the xy axis. So if here's your x-axis, your y-axis, here's 0. Picture that you're taking the entire outside. I'm going to highlight it. Need that highlighter a little bigger, please. Maybe a different color. The entire outside of the circle. And picture that it's like a piece of string. And you're going to snip it right here. And then put it down, unroll it onto the x-axis right here. So 0 is still right here. It's 0. But then we're going to go all the way out to 2 pi. Halfway in between there is pi. Halfway in between there is pi over 2. And halfway in between these two is 3 pi over 2. So we just took the outside of the circle and unrolled it. You guys, sine, so like we're going to do y is equal to sine of x. The sines are all about the heights of the triangles in the circle. So if you have a triangle right here, I'll highlight it. That's a very skinny triangle lying down that has 0 height. So the sine curve at 0 radians, like the sine of 0 is 0. So here we're going to do it in green. That means our first dot on the curve here is 0. Now, you guys, as you travel up around the circle, like if you draw in your triangles, like, your triangles' heights start getting bigger and bigger. If you go up here, like all the heights of these triangles, which I'll highlight in like blue, I guess, these guys, do you see how they're getting bigger and bigger until they get all the way up to here? Now, a lot of people are like, wait a minute, how tall is the triangle at that top? Well, don't forget that it's a unit circle, which means that it has a radius of 1. So that means when you have a super skinny triangle right here up at the top of pi over 2, that triangle has a height of 1. So as sine travels from 0 to pi over 2, it grows from 0 to 1. So let me switch back to black. That means that my sine curve is never going to get past 1. And also, once we get into the negative quadrants, it will never get below -1. So I like that green. Let's do that again. As you travel from 0 up to pi over 2, the sine curve grows from 0 up to 1. So there's the first part of our sine curve. Then, once you hop over the pi over 2, if you go back to the unit circle, like your triangle heights start to get smaller. Do you see as I'm going here that these, the heights of all these triangles, which I will highlight in blue again, they're getting smaller. So it essentially goes back down the curve and goes back to 0. So when you hit pi right here, you have a very skinny triangle lying down that has 0 height. It's all base, no height, which means at pi, sine is 0. So connect there. When I dip into the negative quadrant, these triangles, like at first have very small negative heights, but then they get bigger and bigger negative heights. So highlight those like small, bigger, 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 until you get all the way to here, and then you have a very skinny triangle that has a height of -1. So what that means is as you traveled from pi to 3 pi over 2, that your sine value dipped down to -1. So that's the next part of our curve. Then when you go 3 pi over 2 to 2 pi, like your triangles, I guess I'll draw them in for you guys. They get smaller and smaller and smaller, but still negative. And then eventually, when you get back to 2 pi, you have another height of 0. So this goes back to 0 at 2 pi. There. Now, you guys, what I've drawn, this is called one full period of a sine curve. So this is one full period. Because after that, as you start to go around the circle again, like it's just going to go through the same process. Like it's going to go back up to +1 and then back down to -1. Also, if I was to start here at 0 on the unit circle and instead go backwards this way with a negative direction, they would start at 0 and then go to -1 here. So if you back up this curve over here, like it's just going to continue this pattern of going up to 1, back down to 0, down to -1, back up to 0, up to 1, back down to 0. Like it behaves that way. It's sinusoidal, it's cyclic, it just keeps repeating itself. Whoa. Now, before we do anything with those curves, let's just focus on sine at first. So this is the parent function of sine. It's got a range of only +1 to -1, and it never gets outside of that unless you transform it. So let's do a little example here. Let's sketch y equals 5 sine x from, that's how you spell from. Nice try, Jolly. Try that again. Let's go to 0 to 2 pi, just like a one full period. So let's see. This 5 out in front is going to take the regular sine curve and do a vertical stretch on it. So instead of going from -1 to +1, it's going to go from -5 to +5, but it's still going to behave the same way in terms of the x values. Only the y values are going to change. So here, this will be +5. And then 1, 2, 3, 4, 5, 1, 2, 3, around there. That's -5. This is still 0, the x-axis, the y-axis. And then we're going to go 2 pi, pi over 2, 3 pi over 2. So let's change colors. We'll go purple. It still starts at 0, 0, but then it goes up the mountain, up to +5, then back down the mountain, back down to sea level. Then it goes into the valley, and then back up to 2 pi. Now, if they hadn't said to graph it from 0 to 2 pi, this would continue. It would go this way down here at, this would be like -pi over 2. It would hit -5, and then it would go back up again. And then if you continued this way, it would go up the mountain again and then back down. But they said just to do one full period of it. So there we go. From 0 to 2 pi. Now, let's transform it in another way. Let's do graph y equals sine of x plus 3 on 0 to 2 pi. So, you guys, this 3 on the end here, like, don't forget all the transformations we've done. The sine curves behave the same way as any other function, where that plus on the end is just your vertical shift. So, that means instead of going from -1 to +1, it's going to oscillate around the 3. So it'll go up 1, down 1 from 3. So it means it'll go up to 4 and down to 2. So if I were to sketch my x, y axis like this, Here's 0, 2 pi, pi, pi over 2, 3 pi over 2. I do this thing sometimes where I call them training wheels. Here's how training wheels work. The midline that's normally on the x-axis has been shifted up by 3. So that means if I go up, let me see, 1, 2, 3, that means that the midline, if this is 1, 2, 3, 4, some people call it the principal axis. It's more of an IB term. That I know my curve is going to oscillate around that line. I also know it can only go up 1, down 1, because there's no stretch out in front, like it hasn't been vertically stretched. So it still just is a normal up 1, down 1, like the unit circle. So I know it's going to go up to 4 and down to 2. Now, these dashed lines I put in here are not technically part of the graph. I call these training wheels because they just really help you keep your graph nice with how you sketch it. So if I were working on pencil and paper, I would keep my training wheels in there, and then once I'm all done with the curve, go in and erase the training wheels, because I don't want anybody to judge me that I had to use, a little help to make it look nice. Let's see. It's a normal sine curve. It goes up 1, down 1, but it starts at 3, so starts here. Then at pi over 2, it jumps up to 4. Then at pi, it jumps down to 2. And then at 3 pi over 2, it's back to the center line, and then... what did I do wrong? Oh, I goofed up. Sorry, I skipped one. At pi, it would be back to the center line. Then it would dip into the valley at 3 pi over 2, and then back up at 2 pi. So if I play connect the dots here, hope those sound effects are super crispy in your guys' headphones. All right, that is a sketch from 0 to 2 pi of that curve. But once again, I would probably go back and get rid of these guys so nobody judges me. Oh no, I'll fix it. Don't worry. Oh geez. Oh, I shouldn't have done this. Oh geez. Okay, here. There we go. All right. That's a vertical shift, a stretch. So if this number had been negative, it just would have shifted it down. We could do a little combo. Let's maybe jump just to the big boy. Let's do like a three things happening. Y equals -2 sine x minus 1. Yeah, this is decent enough. So before I even start putting down my axes, I'm already thinking about where my training wheels are going to go. I know that the center line is going to be at -1 because the whole graph got shifted down 1. I know that instead of going up 1, down 1, it's going to go up 2, down 2 because it got vertically stretched. Also, there's this guy right here, a little negative out in front. We haven't done that yet, but this is just going to be we've learned it before. That's a vertical reflection. So in terms of a sine graph, instead of going mountain valley, it's going to go valley mountain because it's going to be upside down. All right, training wheels time. Once again, the center line is -1, and it goes up 2, down 2 from that. So up 2 from -1 would be +1, and down 2 would be -3. So I know it's going to oscillate between, what did I just say? +1 and -3. So if I go to sketch my axes, here's my x-axis. Oh, and we're going to just do 0 to 2 pi on this one, even though I didn't put it in the directions. It's going to make it all the way up to +1. I know that. Its center line is going to be at -1. But then it's going to go down 2 to -3. So this is like 0, -1, -2, -3. I'm going to put my training wheels in on top. I know it can't get past that top line of +1. It can't get past this bottom line of -3. And it's going to oscillate around the center line of -1. Now, let's see. it's upside down because of the negative. So it's still going to start at the center line, but instead of going up the mountain this way, it's actually going to go down into the valley first. Oh, I didn't put my 0. Let's go make this 2 pi. This is pi. 3 pi over 2 and pi over 2. Okay, back to green. So into the valley, right here at -3, lines up with pi over 2, then back up out of the valley at pi, then up the mountain at 3 pi over 2, and then back down at 2 pi. So if I play connect the dots, and you guys, when you're doing this at home, please make the sound effects. It helps so much. And then the graph does continue over here and over here, but I'm assuming that they probably just wanted us to do 0 to 2 pi. I wanted you to do 0 to 2 pi. Then I don't want anybody to judge me, so I'm going to just be very careful to erase most of my training wheels because they're not actually part of the graph. And yes, I will grade you down if I see those training wheels on a test. And I'll judge you too. I'll say it. 2. Cool. What else do we need to talk about? Oh, one last thing. All of this stuff applies to the cosine curve as well. Now, the cosine curve, if you ever forget the cosine curve, go back to the unit circle. So on the unit circle, if you think about all those triangles, going from 0, pi over 2, pi, 3 pi over 2, and 2 pi. The cosine right here is 0. Like the cosine of 0 is 0 because, or no, sorry, it's +1. We're thinking about the x direction, not the y direction. It's the base of the triangle, not the height. So here, the cosine value is +1. Then up here, at pi over 2, it's 0. Then it's -1 over here, back to 0, and then back to 1. So it has a very similar behavior of oscillating between 1 and -1, but really the big difference about cosine is where it starts. Pardon me. So let's get our regular tick mark set up. You should know these very well by now. Pi over 2, pi, 3 pi over 2, 2 pi. Cosine still oscillates between +1 and -1. But remember, with the highlighter, that where it starts right here at +1. So when I go to draw my cosine in, it's going to start here, up at the top. Then as I travel this way, the triangle bases get smaller and smaller and smaller until you get a very skinny triangle right here that has a base of 0. So that means at pi over 2, the cosine is 0. Then the bases get bigger and bigger and bigger, but negative. So it dips down to -1 at that point. Then at 3 pi over 2, the triangle bases shrink, get back up to 0, and then at pi over 2, we're all the way back to +1 again, right around here. Now let's connect the dots. Let me see. You guys, that's one full period of cosine. Notice that it still has an amplitude of 1. Oh, didn't say that earlier, did I? You guys, this distance from the center line up to the top, this is called the amplitude. It still has a period of 2 pi. Let's use a different color. That if I go from here all the way to here, this is one full cycle of cosine. Period is 2 pi. Yeah, it's got an amplitude of 1. It's very similar to the sine curve. In fact, if you were to continue this and go to here and then back down and then over here and back down, if I highlight, let's get a better color, just this portion of the graph. Do you guys see how that's a valley or a mountain valley? So it's like cosine is a sine curve that's just been shifted pi over 2 to the left, which I think that'll come up later on when we do a little horizontal shifting, but we're not doing that today. Today we're just covering a little bit of vertical stuff and some flipping. So you guys, cosine behaves the exact same way. If you were asked to sketch certain things about cosine, really all we covered today is, if we have y equals a sine x plus, let's say d. I think that's a weird jump, but it'll make sense later on. And y equals a cosine x plus d, that these guys, the a values, they control your amplitude. They also, if the a is negative, they'll be upside down. And the d values are just your vertical shift. That's really it that we covered today. All right, guys. I'll be attaching a homework assignment with this, and then just keep doing those quizzes on Wednesday. Reach out via email if you need any help. Remember, my office hours are 5 to 7 by appointment only. Hope you guys are staying safe.